Pennsylvania Transformer Technology, with headquarters in Canonsburg, Pennsylvania, is an industry leader in manufacturing various customized power transformers and voltage regulators. Transformers are devices that transfer electrical energy between two or more circuits through electromagnetic induction. Varying the current in the primary coil of the transformer produces a varying magnetic field, which induces a varying voltage in the secondary coil. The fundamental purpose and benefit of transformers is that they can be used with the same source of power to create greater or lesser currents depending on the requirements of the application. PA Transformer manufactures all of their transformers at their headquarters in Canonsburg. The company runs 2 8-hour shifts per day for 5 days a week for all stages of the manufacturing process. Their current issue is that they have trouble forecasting production time accurately to their customers, which leads to high inventory when they're ahead of schedule and late deliveries when they are behind schedules. Our objective is to develop a system that will improve Pennsylvania Transformer's ability to forecast production times and provide visibility into the manufacturing process to assess causes of variability in production times.
Through our root cause analysis, we found that this issue was due to a bottleneck at their winding process, which produces the multiple coils that make up a transformer. The company currently forecasts their production time based on winding's average of producing 63 coils in a month. However, each transformer is custom designed, and there is great variety from one coil to the next. The physical variables of the coil surely impact the expected time for the winding process, but are not factored into the forecast. Another source of variation is due to worker performance, as some are highly productive while others are not. PA Transformer does not currently have a system to track the time for each coil or to monitor worker performance. Our approach will involve developing a database to store historical data and monitor work in progress for the 17 machines, as well as the queue for this process. This data will then be used to project the expected time till completion for each coil in the queue based on real-time data of the system. The database is used to store, input, update, and access information for historical, work in process, and queue data for the winding station. The foundation of the database are the orders, transformers, and coils table, which have a built-in relationship to show the connection between the entities. The coils table contains information on the physical and electrical properties, start and end time of the winding process, and its status being complete, work in process, or queue. The users for PA Transformer can update information across multiple tables through a single submission of the forms we created for them. Our new order entry form allows the user to add new orders from customers to the queue of the database. The input to transformer type dictates what information is required for coil specifications. Submitting the form then adds the order to the coils, transformers, and orders table as shown. The shift progress form allows users to update the database based on what progress was made during a specific shift. For example, if we enter 5 sections completed out of the 15 sections remaining for the coil on machine 1, then it will update the sections remaining for the next shift to 10. The user will also select the employee who is responsible for the progress in order to monitor employee performance. If all of the sections remaining are completed for a given coil, then the system will first ask to make sure that the coil was fully completed and unloaded during the shift, and if so, during what hour of the shift it was completed. Then it will ask if you would like to assign the next coil or leave the machine as idle. By opting to assign the next coil, the Select Next Coil form will open. The drop-down selections are based on a query run for coils that still need to be made, which are marked as queue in the coils table. As you can see, the machine 1 has been updated to the specified coil, and the time information for the original coil and the coil replaced have automatically been added to the coils table. Opening the worker performance table also now shows the worker ID number along with the progress they made for a coil during a specific shift.
Our forecasting tool is an R program that works hand in hand with the database. The program pulls all of the historical data for completed coils and runs a regression analysis to update our initial model. This updated regression model is then used to provide a forecasted estimate for how long each uncompleted coil will take to be wound. This step updates projections for all of the work in process and queued coils. Now that we have winding times for each coil individually, our program simulates queues at each machine in order for us to generate estimates for the coil's overall time until completion or time in the system. The coil orders are balanced across the machine queues in a first-in, first-out manner, related to when they were entered into the database system. Next, the coil's queue selection is completed by identifying the queue with the least amount of allocated winding time. Now that we have simulated a more realistic queue, our program is able to estimate each coil's time in the system by using its position within the queue to sum an overall hour quantity. We are then able to generate an hour range that we believe will capture that coil's time in the system with 90% confidence. These projections are lastly exported to an Excel file for easy use by the company. Our overall system of the database and forecasting program provides a 39% improvement for the forecasting the average winding times per coil. Our system also provides improved data collection and analysis for the company to better understand their work in process, order queue, and previously completed orders. Lastly, our program increases visibility into the overall winding process and employee performance for the management that can be the groundwork for continuous improvement.